we go. All right, so we are recording and we are continuing with the topic that we left on Monday, and that is still in conditional statements. Okay, let me go back and open up in a new tab. So there we go. Conditional statement. This is the assignment. We're not ready to talk about it yet. All right, so let's go to the syntax of a conditional statement, and we'll start from here. All right. So do we have any questions about what we have talked about? Yes. hmm A token and an element. Where do you see element? Okay. It's not the same thing. No. No, it is not. Um, so a token is a placeholder. Basically, it is a placeholder. Mm, no, it is not. So when you see the angle bracket P and then the angle bracket, slash P, they are not placeholders. They are what we call tags, TAG. So the tags, one starts, the paragraph, the other one ends the paragraph. But they're not placeholders because, that is actually what is in the HTML document. But in this case, when we look at a conditional statement, it can expand to, the following. These are terminals because they're boldface. So is this, they're terminals. This one is not a terminal because it is not boldfaced, it is italic, and it is also shaded a little bit gray in the background. And so is this, and so is this part here. So these are tokens. So we only have, when you look at the syntactic rule in BNF, you have two different things. On the right-hand side of this symbol here, which is representing can expand to, you can only have one of two things. Okay, each item can be one of two things, and you can have a sequence of those things. So one is a terminal, which is what you actually have to type in the program, and two, it can also be a token, which then can be expanded to something else. Okay, sorry. So you might have been dropped because you have not participated in the role taking activity, and I do not know your name. So I don't even know who I have to excuse. So let's handle this after the class. So for the time being, you just kind of have to listen to the lecture. Okay. hmm All right. So is that okay? That am I explaining the concepts okay? All right, cool. All right. So I think last time, we did talk about, this, diagram here, which is called a flowchart. I would use the concept of a flowchart only at the very beginning of this class. We'll stop using flowcharts, as soon as we have introduced all the control statements, all the control flow statements, which basically allow the flow of the logic not to go linear, like just one by one in a sequence anymore. So do we have any questions about the material that we have already talked about? Okay, no questions. All right. So now we also talked about logical operators. I remember that we talked about operators. There are um, three operators in basically all programming languages have three different operators. One is called conjunction, which is the word and then we have disjunction, which is the word or, and then we also have negation, which is the word not. And I believe all three operators were covered in the previous class. Is that correct? Okay, very good. So now we go back to the example, okay? Because the idea is I want to find the maximum of three variables, x, w, x, and y, and I want to store the maximum into a variable called z. So that's the purpose of the logic. So the logic or the code to do that is already done here. If w is greater than or equal to x and w is greater than or equal to y, that makes w the maximum. And I can now use w to overwrite the variable z, and I'm done. Okay, first of all, does that make sense just reading line 1 and line 2 of this code? Okay, so far so good. Okay, so this else is basically saying, what if this condition is not true? In other words, what if W is not greater than, what if it is not the case that W is greater than or equal to X and W is greater than or equal to Y? Well, one thing we know for sure is W is not the maximum. Does that make sense? So that means the maximum is between X or Y. Now, I could have simplified the logic here because this is not really needed anymore. By the time we get here, we already know that. So the only question is, between X and Y, which one is greater? If X is greater than or equal to Y and X is greater than or equal to W, then X is our maximum, and then I store X into the variable Z, which is, because that's the objective of the algorithm. What if that is also not true? What if, it is not true that W is greater than or equal to X and W is greater than or equal to Y, and it is also not true that X is greater than or equal to W and X is not greater than or equal to Y? What is the only option left if I need to find the maximum of the three variables? Which one has to be the maximum in that case? Y has to be the one, okay? So if these two conditions fail, then we fall through to the last else here, which means, okay, at this point, I know that Y has to be the maximum. I don't need to compare anymore. And so I store the value of Y into Z, which is, basically what the algorithm is supposed to do, which is find the maximum between W, X, and Y, and store that maximum into variable Z. Okay? So do we have any questions about the logic itself? Not so much the syntax, but just the logic of what I described. Okay, I don't hear any questions. Is it because there are questions, but some people do not know how to formulate a question, or is it because there really is no question? Everything is all good at this point. Okay, I want to remind people that your professor, not just me, all your professors are not mind reader, as far as I know. So if you do have a question, I cannot read your thoughts and you'll be prepared to answer the question unless you ask the question. Okay, so I just want to make sure that we are ready to move on, you know, and give you guys a little bit of time to think about it. So we are really ready to move on. Okay, all right. All right, so the corresponding flow chart is going to be look like this. Okay, so I know this is a little bit harder to read, so I will try to shrink the screen a little bit just so that I can fit enough logic, onto the projection. Okay, there we go. I'm going to read this. Okay, so if you watch the recording, you should be okay. So this is the starting point, which means everything starts here and then we get to this decision point. All the diamonds, okay, with text inside are decision points. In other words, you read a question and then you try to answer the question with either true or false as an answer. Okay, so in this case, the question is, something that we read a little bit already. W is greater than or equal to X, and W is greater than or equal to Y. This little symbol here, double ampersand, means conjunction, which is corresponding to the English word of and, A-N-D. Okay, and then because that is a question, it can be answered with two possible answers. One is true, and the other one is false. If the answer is true to the question that is being pointed to right now, then we follow this path and then we go like, okay, in that case, we are confirming the W is the largest of the three. And as a result, Z should get the value of W because Z is supposed to be storing the maximum of the three. And then after that, okay, if I were to scroll down a little bit here, you can see that after this, I don't bother with anything else of this part of the flow chart. I just go to this little diamond here. So diamonds can also be used to merge two branches into one. And after we merge those two branches into one, I proceed to the end of this particular pseudocode. Is that okay? All right. So now the question is, what if? The answer to the question of is it true or false that w is greater than or equal to x and w is greater than or equal to y? What if the answer to that question is false? Then we follow this other branch here, okay, which is called an else branch. So we follow the else branch, and then we ask another question. Okay, so now we have another question here, which is it true or false that x is greater than or equal to w and x is greater than or equal to y? Once again, we have two paths coming out of the diamond because depending on the answer to that question, which is either true or false, we can follow one of two possible paths. If the answer is true, then we follow the then branch, which then go to a process block. Rectangles mean processing, and in this case, we take the value of x and then we store that into the variable z, because in this case, if it is true that x is greater than or equal to w and x is greater than or equal to y, then that makes x the maximum of the three variable. So that means, if I store x into z, then z has the maximum. And then we proceed to the merge diamond, and then the output or the exit of this merge diamond goes into the in of another merge diamond, which then exit to the end. So you follow the arrows, okay? That's basically all you need to do is to follow the arrows until you get to a diamond. Then you have to ask a question, and then depending on the answer to the question, you have to choose one of two paths. So now the third path is to say, oh, the answer to this question is also false. So that means w is not the maximum, x is not the maximum. We only have three variables, so y has to be the maximum. So that's why we now follow the false branch here, and then we make a conclusion that y is the maximum of the three, store the value of y into z, and then we get to this merge point, then we go to this merge point, and then we end. So are we understanding both the syntax of this particular pseudocode as well as the logic behind the syntax, what the syntax is trying to specify? Nope. Okay, so which part do you want me to expand a little bit on? Okay, so if we don't use the else if, we have a regular, just a simple conditional statement. That's what it looks like. You have a single your starting point, you get to a question, and then you answer the question with either true or false. Depending on whether the answer is true or false, you perform an operation corresponding to that branch, and then each branch will merge based on this diamond, and then we are done with the construct. So this is the diagram corresponding to this code over here. Is that okay? So, okay, so let's take a step back, okay? There are two main concepts that we have to understand here. One is the syntax. In other words, what are the rules about the ordering of if, the open paren, the close paren, the statement that specifies what we need to do if and only if the condition is true, the word else, and then the statement to specify what do we need to do when the condition is false, if and only if the condition is false. So those are the pieces that we need. Okay. The question now is how do we express that logic? So let me ask you guys a question. Is the hang up with the flowchart, understanding what the flowchart is trying to represent, or is the hang up on the syntax of how we specify the logic of the flowchart? Hmm? The syntax, okay. Any other? Hmm. What is what? So so the hang up is okay. So you're understanding which part? Are you understanding the flowchart, or are you understanding the actual code? Okay, so understanding the code is what you're having trouble with. Okay, so let me see if I can do this. Okay, so I'm gonna use the tablet. Okay, so this is getting recorded, so you guys don't have to frantically copy everything, but do write down, the thoughts that you're having. So this way, because that's the only part I cannot record are your thoughts. All right, so I'm starting up my tablet. Okay, there we go. And go back to my notepad here. And that's from my other class, so we're gonna skip that. All right, so there are two main concepts. Okay, so let me start with the part that I think most of you understand already, which is the flowchart. Does everybody understand the flowchart? Okay, so let me just repeat the flowchart here. Okay, so the flowchart starts with a start. Okay, so that's the symbol for starting. And then it goes to a diamond, which is asking a condition, a question. So I'm just going to call this condition, which is a placeholder. Okay, it's basically an expression that evaluates to either true or false. Okay, and out of that diamond, you have two branches. Okay, one branch is labeled true, the other branch is labeled false. So basically, depending on the answer to the question, which is the condition, you have to follow one of those two paths out of the diamond. Are we good so far? Okay. And then we have a block here, and I'm going to call this then statement. Okay, then statement. And then we have another block here, which is what I call the else statement. These are placeholders. Okay, in other words, I'm not saying exactly what needs to be done. I'm just saying that, yeah, this little block here is a placeholder of what needs to be done if and only if the condition is true. And then this block here is specifying what we need to do if and only if the condition is false. Okay, but it doesn't, depending on which side you go to, each side will merge to another diamond. Okay, so diamonds are used to either split a path into two or to merge two paths into one. Once these two paths merge into one, then we also go to a terminal. Okay, not in the sense of syntax, but in terms of the flow of the logic. This is the starting point, and this is the ending point. So the first question is, do we understand the template? Okay, it's the structure of every conditional statement. Every conditional statement looks like this. Now, there are some times there's nothing to do with the else statement. Okay, fine. Okay, leave it empty. Don't specify anything. But every conditional statement has all of these components. The most important part of the components will be the condition, which is a question, where the answer is either true or false, a then statement, which is what you need to do if and only if the condition is true, and an else statement, which is what you need to do if and only if the condition is false. Those are the three main key pieces of a conditional statement. Are we good so far? Okay. So you would think, hey, if I can just draw pictures and have the computer to understand the logic through the picture, that'll be great. Okay. However, graphical programming is possible. Okay, there are programming languages out there that is graphical. In fact, I think the Unreal Engine, has a way for you to specify logic through the blocks like this. Okay, there's a program called Scratch, where you can do coding kind of like this too. Not exactly the same, but close enough. Okay, but the problem with graphical programming is if you need to change your program, if you need to insert something or delete something or move something around, it is chaotic. Okay, it takes a lot of work to adjust the picture if you need to change the logic. And how often do you think people need to change the logic or revise the logic of programs? All the time, a lot. Okay, so that means, even though this may be easy to understand, it may not be the best way to encode or um, to represent the logic. Okay, so what we do to represent the logic is the syntax of the language. Okay, so that's why the syntax of a programming language comes into play, is we need a more concise way to represent exactly this logic, but in text. Okay, all you need is Notepad in Windows in order to type the program. That's what we want. Is that okay? It's the rationale of representing the logic in the flowchart in text. Does everybody understand the importance of that? Okay. But to specify the text equivalence of this thing here, now we need to introduce the concept of syntax. In other words, we have to help the computer to go like, okay, go find the condition here. Go find the then statement over here, and go find the else statement over here. And that's why we have the syntax. That's why we have the grammatical rules. It's just like I mean, I know I don't speak perfect English, okay, but you're still understanding me for the most part, okay? And that's because we have a common understanding of the grammar of English, okay? You have a good enough understanding of it. I have a good enough understanding of it. So when I formulate the words using that syntax or using the grammatical rules of English, you guys go like, okay, I can process that. Okay, I can extract what is the subject, what is the verb, what is the object, and so on. Okay, it's the same thing with programming. You need to have a structure so that the computer can understand what you're trying to express. Is that okay? So now we look at the syntax, and the equivalent syntax of this particular picture here is like this. Okay, if open paren and then condition. Okay, and then we have the then statement here, and then we have the else word, and then we have the else statement here. Now, in this form, it is really difficult to see which one is a terminal and which one is not a terminal. So I'm going to underline the actual terminals. So these are the terminals, which means they need to appear verbatim in the program. Whatever is not underlined is a token, which means it is just a placeholder. So how many tokens do you see on the syntax side? Three, exactly. And how many boxes contain placeholders in the flowchart? Also just three, exactly. So the condition is this condition here, okay? The then statement is the then statement here. The else statement is the else statement here. Is that working out okay? So yes, go ahead. You mean the underlined word else? So the underlined word else is so that we know how we can divide between the then statement versus the else statement. It is a construct that is needed here in order to give structure to the code. Okay, because otherwise, it's not going to be clear to us, which one is the then statement and which one is the else statement. Now, trust me, we could have invented a programming language that does not need the else keyword here. Okay, but that programming language would not be easy for us to read because when we think about if then and then we usually want to use the word else to specify, hey, whatever is following the else is what you need to do if and only if the condition is false. Okay, you can think of instructions that you give to other people. You can say, if it is a rainy day, then bring an umbrella, else bring sunblock. Okay, so that word else is to emphasize it is a separator of what you need to do when something is true versus what you need to do when something is false. Is that okay? Does that kind of help explain why we need that word else, which is underlined, which means it is a terminal? It is, you have to spell it as exactly ELSE. All right. So I'm going to pause a little bit here so that you guys have some time to process this and see if you have any questions about what you see on this picture. Because this picture shows you, what the flowchart, which is what we want the computer to do, versus the text representation of the flowchart, which is how you need to formulate the logic in text so that we have a text file for the computer to understand the logic of what you want to specify. We're okay. Any questions? Okay. Template. This is more like a template. So hmm, think of this side here as a form, that has not been filled. So you got these empty boxes, right? This is where you need to put your first name. This is where you need to put your last name. This is where you need to put the date. This is the street address. This is the empty space for the street address. This is where you need to specify your zip code. This is where you specify the city. This is where you specify your phone number, blah, 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 and so on. So that's what the syntax here, or the meta syntax, is trying to specify is, okay, what does the form look like? Okay. But exactly what do you want to specify as the condition? Well, I mean, when you're making the form as a template itself, obviously you don't know exactly what the condition is going to be. It's just like, if I want to make a form for, like an ad form so that you guys can add to a class, I don't know whose name is going to be on it. I'm just going to leave a box, okay, and have a little label next to it and go like, okay, last name goes here, first name goes here, but it's blank. So the token is equivalent to the blank space on the form. Are we okay? Okay. And then the terminals and also the ordering of the tokens is kind of like the flow of a form. Okay. Where do I put my your first name on this form here? Well, you kind of have to read the template of the form to know where you're supposed to put your first name, right? Where do I put my last name? Where do I put my social number, social security number? Where do I put my student ID? So that's the structure of a form. Just like, in syntax, what you see over here, that is the structure of the form. Each token is an empty space to be filled later on. Is that okay? Okay. I can see, part of the difficulty of, teaching this class, and understanding, how to write programs is the concept of abstraction. Okay. So now the question is, okay, some people may be asking, so what exactly is abstraction? Well, let's look it up. Okay. I know it is not directly related to this class, but I think it is actually a very important topic to go over because, once we understand, what is abstraction and how it can be difficult, to, for some people to grasp, um, I think that's important. So the quality of dealing with ideas rather than events, and freedom from representation qualities in art. Okay, so we choose, the first, okay, the first one. So now we can also ask Chat GPT. So this is, kind of my thing is, I don't hide the fact that I sometimes use, Chat GPT because, um, it is a interactive way to inquire something. Okay. So it's not like, I think some of your other professors, especially in, let's say, your history or English writing, your professor may say, oh, don't use, ChatGPT. Well, it depends on how you use ChatGPT. Okay. If you're using ChatGPT to help you get a better insight to learn something in a more effective way, it's not bad. If you use ChatGPT to write the entire essay or to answer the question itself, it's not so good. Okay, so it depends on whether you use ChatGPT as a learning tool to help you learn better, or whether you use ChatGPT so that you don't have to do the work in order to learn. Then you are not learning either. Okay, so I'm saying you not to direct to any specific person in this class, just, the hypothetical person who is using ChatGPT. So I will ask you the question, okay, which is why is why are hmm, what okay. So formulating the question itself is part of the thought process. So I'm going to ask, what are some of the difficulties of learning abstract concepts such as the syntactic rules in of a programming language? Okay. So Sam Altman, somebody asked, Sam Altman, the CEO of OpenAI, okay, and the question was, what is the most important skill for software developers in, basically from here on, okay? It used to be, okay, you need to know a bunch of programming languages, C, C++, C Sharp, JavaScript, Python, and so on. So it is not about knowing anymore. It is about how do you ask a question. Okay. I can also send you guys the article. So we'll see what ChatGPT has to say about this. Lack of immediate intuition. Unlike concrete concepts, abstract rules lack direct real world analogs. So that's kind of what I was trying to do earlier is to, okay, let me go back to the picture so that it's concrete. So I was trying to look at this and go like, okay, think of this as a form. Okay, there are three empty boxes on that form. One empty box says, what is the condition? Okay, what is the question that you need to ask that needs an answer that is either true or false? Another box is trying to specify, okay, so tell me what I need to do if and only if the condition is true. And the third box specifies, tell me what I need to do if and only if the condition is false. It is a physical form with three boxes. And those three boxes need to be filled, okay? Because when I make the form, when I make the template of the form, obviously I have no idea what you want to do, what you want to achieve. But when you actually write the code and you identify that you need a conditional statement, then at that point you should be able to fill in the blanks. You should be able to fill in, okay, I need this. This condition is what I need to evaluate. This action is what I need to perform if and only if the condition is true. And this action is what I need to do if and only if the condition is false. So think of the tokens as empty spaces in the form. Okay. But I do want to go back here, okay? High cognitive load, remembering syntax, semantics, and structure simultaneously require managing multiple layers of information at the same time. Well, I'm not going to lie, okay? I try my best not to lie on a daily basis, okay? So this is what it is to become a developer, okay? So there are people who are intrinsically the brain is wired to get this stuff like that, okay? And they can learn really quickly. And there are people where their brains are not wired to do this, okay? It's just like with everything else, okay? We are all unique individuals. We have our strengths, and those strengths may not be the same from different people. Okay, so it is important to understand what your strengths are, when you're considering a career option. But I can tell you ahead of time, if you want to be successful in as a software developer or to work in computers, anything related to computer science at all, you need to master, the ability to learn abstract concepts. Now, is that something that is it something that you're born with? Or is it something that you learn? Okay, that's nurture versus nature, right? So the answer is a little bit of both. Okay, for people with a curious mindset, they have the nature to help them learn things that are abstract, to extract the pattern out of things. But some people do not like that. Okay, some people like things that are concrete. Okay, so when some people like to work on cars, okay, because like they like the smell, they like the sound, they like to be able to touch, everything. I don't. Okay, I don't want to get my hands greasy. Okay, and I cannot tell whether an engine is knocking or not, just by listening to the engine and open the hood. But some people are very good at that. They can listen to the engine running and they can go like, "Oh yeah, your cylinder three is not working correctly. I think it's the exhaust valve that is not opening correctly." I go like, "It sounds exactly the same as every other car." Okay, so that means you need to find out where your strengths are and where your interests are. Okay, because you don't want to do something that you're innately not interested in doing. All right, so moving on. Syntax without meaning. Okay, early exposure to programming syntax often lack immediate purpose, making it difficult to see why certain rules exist. I'm trying to overcome that, okay? Because I want you to kind of look at things from the perspective of the compiler or the interpreter, basically the computer um, component that actually reads the code, because you're understanding that is important to understand why do we have this else here? Well, the else is here to separate the then statement from the else statement. Okay, so it's clear which one is which. Memorization versus understanding. This is always a good discussion. The difference between these two. Memorization is just that. Okay, I give you a phone number and I ask you what was the phone number that I just gave you like 5 seconds ago. If you have good memorization techniques and capability, you go like, oh, easy. Okay, I can recite all 10 digits just like that. And I can tell you right away, I suck at memorization. Okay. Um, when I was in elementary school, middle school, and high school, I was at the bottom of my class. Okay, then you guys go like, oh man, I chose the wrong professor. Okay, because my professor is doing so poorly academically speaking. When I get to college, the first year I got into college, it's like, wow, this is easy. Nothing is easier than college level classes compared to high school, middle school, and elementary school. Because in college classes, especially in math and computer science, I don't need to memorize anything. All I need is to understand the concepts. And I can understand concepts just like that. I just cannot memorize. Okay. So that's memorization versus understanding. What is the difference? Understanding means you make connections between the concepts. You understand the what, the how, and the why of things. So everything become connected. They are not just islands in an ocean. All of these islands have bridges across them. Okay, so think of that mental picture. Okay, error feedback with clear solution. Syntax errors can be cryptic, and debugging requires understanding both the mistake and the correct syntax. So once again, it's getting to both the syntax versus the logic, and both are needed in order to become a successful programmer or software developer. We are going to skip this one because it does not apply as much in this class. In CISP 360, this point becomes super important because you will be actually writing programs and you'll be running those programs. Okay, so you will get errors. Basically you can get syntactic error. You can also get runtime error, which means the logic itself is problematic. Abstract thinking requirement. Programming demands logic, pattern recognition, and abstraction. That is true. Okay, so the AI response is not wrong. Okay, it is actually true, which can be difficult for those unfamiliar with mathematical or structured reasoning. So the question is, do you like to solve problems? Do you like to solve puzzles? So people who like to solve puzzles, they may not have taken a programming class before this, but the logic comes easier for those people because they understand, oh, okay, I can get the logic. Okay, you can read a detective story. Okay, you can follow the detective story and you can even predict what the next two chapters will be about. Okay, and you have your prediction of, okay, it can be this person who committed that crime, can be this person who committed that crime, but at this point I don't have enough evidence to point to which person. Okay, so you can follow along with the logic of a detective story, and you can even deduce as you read the story and narrow down the number of suspects. Okay, if you can do that and if you enjoy doing it, then um, this part here, demanding logic and structured reasoning, you got that down already, even though you never took a class in that. But because of your own interest and because you spent time doing it already, you already have developed some of those skills. Is that okay? All right. So syntax variation, we are not too concerned about this because we're focusing on one and only one programming language in this class. Lack of immediate visual representation. Well, do you think I was doing something to try to at least overcome a little bit of that? And what do we call those things? Starts with an F. Flowcharts. Exactly. So flowcharts are exactly why I what I use here to try to give you some visual representation of the abstract concept that is that I'm trying to represent using syntax. Frustration from lack of progress. Okay, we're that is yet to be seen. Okay, so we are not going to talk about this one too much. Okay, well, and ChatGPT even asks, would you like strategies for overcoming these difficulties? So that means if you are having a little bit of difficulty getting corresponding the diagram, the flowchart with the syntax or understanding what are tokens versus what terminals are and why they exist, then you might want to say yes, please give me some strategies for overcoming these difficulties. Okay. If you guys want to, I can make the prompt available to the whole class. Then you guys can just kind of click on that link, ask the same question, and then follow up with your additional questions. Okay, this is one way to use ChatGPT or AI in a class setting that is in a beneficial way. So are we okay so far? Okay, good, good. And this is also why personality tests are also useful. Okay, I have talked about a few. So one is called MBTI or Myers-Briggs Type Indicator, and this is a free test that you can do for yourself. Um, I believe that it is always useful to identify your own personality type. You can always double check. Okay, some people do not like the result of these personality tests. It's partially because they have a certain um, there's a certain ego of how we look at ourselves, and then the test is giving those people a conflicting image of how they see themselves. Okay, so when there's a discrepancy, then people go like, I don't think I'm this person. Okay, I always think that I'm more like that instead of what this test is telling me. Okay, when I took this test, my wife of 20 plus years was actually impressed by the outcome of this test and how it described me. It's like, wow, it's almost like someone, the computer, okay, has known you for decades, just by taking a test. Okay, so that's one. And then this one is free. The other one is not. It's called Clifton's Strengths. There we go. So this one is not free, and I do not necessarily want people to pay for it. But for those of you who actually can afford like $60 to pay for the test, it is actually kind of interesting. This one gives you a ranking of your strengths. So there are like close to 60 different traits, okay, and it will rank those traits. So it will give you the top five, and then the top 10, and then the top 20, and so on, and then you can get to see where your strengths are. Okay, the idea is you want to choose a career, you want to choose something that will that allows you to lean on your strengths. Okay, so in my case, I really lack what they call executive function, which usually means seeing to get things done, seeing through tasks and so on. So I would be not a good choice as a CEO. Okay, definitely a poor choice as a CEO. But I am, I focus more on ideas. Okay, I focus on problem solving. So this is not really a bad job for me. I can be a very good programmer or a software engineer. That's actually what I did in industry before I started teaching here. Okay, so these are tools to help you understand yourself. And once you understand yourself a little bit more, you can develop strategies that work best for you. Okay, because one strategy may work for some people, but it may not be the right one for you. Is that okay? All right, so I'm digressing a little bit from the course content, because I think it is important to talk about these things, even though some other classes or some other professors may not agree, and they think these are just kind of bogus stuff. Okay, so are we good? Are we ready to continue? Okay, excellent. All right, so we are continuing with the else if here. Okay, so we are going back to the more complex logic that we were working with, which is this part here. Let me go back in and zoom in a little bit. So this logic is basically saying if this condition on line 1 is true, then we go to line 2, and line 2 is the only thing that we do. But if the condition of line 1 is false, then we evaluate the condition of line 3. If that condition is true, then we execute the statement on line 4. And if not, then we just go to the statement on line 5. That's kind of the logic that is being represented by this code, which is actually proper C++ code. The logic is also can be encoded into a flowchart, which I described a little bit earlier. So are we doing okay, better now, in terms of corresponding the syntax or the code itself with the diagram, with the flowchart that describes basically the same thing, but in a more pictorial, way, a more graphical way. Okay, yeah, okay, go ahead. Okay, so let me use another, graphical way to look at this whole thing. Remember the thing about a form? So this is a blank form. I'm trying to make a blank form. So on the blank form, I'm saying, okay, tell me what is the condition. I leave some blank space for you to write the condition itself. And then I basically say, what to do. Okay, I'm going to spell it out. What to do if the condition is true. And that has its own little space here. And then I would also say, what to do if the condition is false. And I give you some space to write that too. Is that okay? So this is what goes here. This is what goes here. And this is what goes here. Okay. Okay. Gotcha. All right. I gotcha. Yep. Okay. So let me show you the last diagram first, which is this. Okay. This is how we analyze the text that comes with the code, and then we use those rules to go like, oh, these things belong together. Together, this thing is this part. Together, this thing is this part, and then we just try to piece the whole thing together. So it's kind of the reverse of making the form. You're now reading the actual text, and then you're trying to identify, oh, this is a part for this, this is a part for this, this is a part for this. You're reconstructing the structure of the statement that you have constructed. Now, we do this all the time, like even right now, okay? Because when I say something, okay, like that puny dog is trying to attack that feisty cat, okay? Do you guys understand what I just said? Okay? Why? Because in your head, you are already reconstructing the structure of the sentence. That puny dog, okay? Puny is an adjective. It is expecting a noun after that. So the puny dog is the noun phrase, okay? But because it is at the beginning part of a sentence, it is stating the subject, okay? Who is performing the action? What is the action? It's trying to take on, okay? So you put all those words together is trying to take on, okay? Trying is the verb, okay? To take on is to describe the verb. I'm not an English major, so I cannot tell you exactly how those things are supposed to be called. But in your head, you are putting those things together. Is trying to take on describes the action. So you have the subject, you have the action. What is the action applied to? What is receiving that action? The feisty tag, right? So you're already doing all of this in your head. Okay? The computer needs to do exactly that. When you say if blah 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 else blah blah blah, The computer has to go like, okay, wait, let me understand which part is the condition, which part is the action to perform if and only if the condition is true, and which part is the action that I need to perform if and only if the condition is false. So that's the rationale behind the syntax. Okay, because once we understand the rationale and why it is here, then it becomes a little bit easier to apply it. Okay, so let me use a simpler example. Okay, so I will go back to the simpler example and look at the syntax chart of that thing. So we'll go back to this one over here. Okay, so we'll go back to this one here, which is simpler. Okay, and I will copy it to my tablet first, and then we'll switch to the tablet, so then we can say, oh, okay, how do we recognize the different parts of this whole thing? So now let me go back here. Okay, I'll do something slightly better. I'll do this trick here and open it with this program and then make it always on top. There we go. Okay. And then switch to the tablet screen. Okay, so we'll open a new page. Come on. There we go. All right, so we have these things. Okay, if open paren x is greater than y, z equals x, semicolon, else z equals y. Okay. So as I have said in this class already, C and C++ do not care about lines. Okay, you can break it into one word as a line. You can also combine the entire thing onto one single line. It does not care. Yep, go ahead. Spacing. So as long as you have either a new line, a single space, or any number of spaces or any number of tabs, they're all considered the same. So you can basically break it up so that if is one line, open paren is one line, x is one line, greater than is one line. You can make this program like as long in terms of line number as you want, or you can just fold the whole thing onto one single line. The programming language actually does not care. Okay. All right. So we look at this, and we now try to look at this from the perspective of the computer. Okay, just like when you guys are listening to me in your head, you are parsing my sentences. Without thinking about it, you're trying to identify, okay, who is the subject, who's performing the action, what is the action, and who's receiving the action, and how does this relate to everything else that we have been talking about. Your brain has been working on this. So now we're trying to look into how the computer would look at this sequence of characters, okay, or words or letters and punctuations, and then it will do some processing. So the first thing it sees is if, okay? So as soon as it sees the if, it goes like, oh, okay, this is a terminal that goes to the beginning of only one kind of statement, which is a conditional statement. So right away, after seeing the word if, the compiler understands, oh, what follows has to be a conditional statement, okay? So knowing that what follows is a conditional statement, the compiler automatically says, okay, I'm supposed to see an open paren, which is a terminal. I'm supposed to see a closed paren as a terminal. I'm supposed to see a then statement as a token, as a placeholder. I'm supposed to optionally see an else here, and also optionally see an else statement. So those are optional. Okay, so now the compiler has expectations of what should be following the word if. Is that okay? All right. So the word if sets up expectations on the computer and go like, okay, I'm expecting these things here. Oh, by the way, I missed one thing, which is the condition. The condition is a token that goes between the parentheses. Are we good so far? So now the computer sees the open parenthesis and go like, okay, good. This is what I'm expecting. I'm seeing it. Good. But after the open parenthesis, the computer goes like, okay, I'm supposed to see a condition. And well, guess what? It is seeing a condition here. Okay, this is a condition. So it goes like the compiler is happy. Okay, I'm seeing what I'm supposed to be seeing. And then right after the condition is supposed to see a closed parenthesis. We are seeing the closed parenthesis too. So everything is now going as expected. After the close parenthesis, the computer goes like, okay, I'm supposed to see a then statement. So now it goes like, okay, what kind of a statement I'm encountering here? It is looking at the Z here. It's not if. It is not one of the keywords to identify a particular type of sentence or a particular kind of statement. So the only way they can start with a non keyword, okay, if is a keyword, why is a keyword, do is a keyword. But if it's none of those, then the compiler goes like, oh, okay, the only kind of statement I can kind of expect here is an assignment statement. Okay, so once it understands it's supposed to see an assignment statement, then it goes like, okay, an assignment statement starts with the left-hand side, so this must be the left-hand side of the assignment statement, followed by a equal symbol, and this equal symbol is what we expect in an assignment statement, and then followed by a right-hand side. Okay, this is an assignment operation, but when you have a semicolon ending an assignment statement, the entire thing becomes an assignment statement. And the assignment statement is just a statement, which is what the then statement you can expand to. So now it recognizes that, oh, okay, z equals x semicolon is my then statement. Okay, what can be after the then statement? The word if, else, okay, which is optional. But in this case, we do see the else word, right? So now it goes like, oh, okay, we do see the else word here. So we are expecting the else statement after that. So once again, it goes like, okay, but it can be any statement. But since the next word starts with a z, which is not if, it is not while, it is not do, it's not for, it's not one of those keywords, then the compiler knows, oh, okay, I must be expecting an assignment statement right now. So once again, you're knowing that it is an assignment statement. It goes like, okay, this must be my left-hand side, okay, and after the left-hand side, I'm supposed to see an equal symbol, which is good, and I'm supposed to see a right-hand side, which is just an expression. It's all good. This is an assignment operation, and when the assignment operation is followed by a semicolon, now we have an assignment statement. An assignment statement is just a statement, which can then fill the spot of an else statement. So that's okay. This is way oversimplified in terms of what the compiler actually does, but it is sort of right. Yep. Yep. hmm So is that okay? Is that giving you guys a better context of how to look at the things that we have been in what I have introduced up to this point? Yes. hmm Correct. So if you forget about that semicolon, okay, let me point to which semicolon we are talking about. If you forget this semicolon, the compiler will say, oh, I'm expecting a statement, but I'm not seeing a statement. Because without the semicolon, z equals x is an expression. It's an assignment expression, which is not a statement. So an expression is not expected to have else as a word to follow it. So in that case, the compiler will give you an error. It's like I'm not expecting the word else right here because z equals x without the semicolon is not a statement. Can you ask that question again? hmm Mm. Okay. So the computer does not understand what you want to accomplish. It can only understand whether the syntax is correct or not. So okay, first of all, x plus x or 2 times x is not Boolean. It does not give you an answer that is either true or false. Now that's not entirely true, but I'm not going to get into type coercion and stuff like that at this point. So with Java, okay, not C++, but with Java, if you put x plus x and x is an integer, the compiler would actually give you an error because it's not a question that ends with true or false. It is a numerical kind of answer. So, yep. But if you were to ask, is x greater than x, which doesn't make sense, right? X cannot be greater than x. The compiler does not care. It does not understand what you want to accomplish, that you have just mistyped y as x. It did not understand that you want to find the maximum of the two. But syntactically, is it okay? Can we compare x, which is a numerical value, with x, which is also a numerical value? Sure, not a problem. So in that case, you have a program that is syntactically correct, but semantically it does not represent what you want to get done. But the compiler cannot help you with the correcting the semantics. It can only help you with the syntactic side of things. All right. Are we still doing okay so far? Okay, so because I want to give you guys the context of why we talk about the BNF, why we talk about the flowchart, and how do those two things relate to each other. One is easy for us to understand because it's visual, you just follow the arrows. The other one is how the logic is actually represented in text. Okay, we good? Okay, so after this, I wouldn't say heavy duty, but it is a more involved of a discussion. I'm going to take roll, just kind of so that you guys can relax your mind a little bit here. Okay, so I make this available now. It is roll taking for today, which I believe it's the fifth. It is the fifth. And the word that you use to answer in this case is branch. So sign in to Canvas and participate in this critical quiz. It does not have a question, so you would get a score of 0 out of 0, but that tells me that you are here in class. Hmm? Branch. It is highlighted on the screen right now. Mhm. Branch. All right. Does anyone need more time or have any difficulty getting into the quiz? Okay, I don't see any questions or hands. All right. So now we can continue with our discussion here. All right. So your homework assignment, I'm going to assign your homework assignment now because we just talked about the logic. You have the flow chart. You also have the language. So I am going to actually specify the due date of the conditional statement assignment. It had a due date or it has a due date already, but I'm going to postpone that to 1 week from today. And since today is the 5th, that means it will change to the 12th as our new due date. Okay, so there we go. Click save. There we go. All right, so next Wednesday, you have a homework assignment due. Okay, do you guys have any questions? Nope. Okay, because if you have any questions, please direct the question to me. And otherwise, please, keep your conversations, to a minimum during the class. Yes. So this one does not need to be in a Google spreadsheet. It can be in any spreadsheet. Right. Yeah. Yes. So let me go to the trace here. So if this is the logic, and if X, Y, and Z, they're all twos to begin with, then this is the trace of the example when we have a precondition of X, W, X, Y are all twos to begin with. So you have to give me three scenarios. One scenario where W is the maximum, but you cannot reuse this one. One scenario is when x is the maximum, and then one scenario is when y is the maximum. But you have to follow this, um, I guess the standard of a trace, and basically make sure that you indicate which lines we go to in each case. Yep. All right. So that is your homework assignment. You have 1 week to do it. Okay. And let me go back to the module here. All right. So there's one whole section here that talks about what is exactly else if. Okay. Depending on the programming language, else if may be an actual language construct, but in the case of C++, there's actually no syntactic construct called else if. So in this case, the find max, this entire statement, okay, this conditional statement here is the else statement of the outer conditional statement. In other words, we have one conditional statement where one part of it is containing another conditional statement. So this is where things get a little bit tricky to explain. So if I go back to the tablet and go back to this picture here, it basically means if this is the, I guess, the template card for a conditional statement, one part, which is this part here, is a miniature version of this, but it is embedded here. So we have a conditional statement itself being the else branch of yet another conditional statement. This concept is called nesting. Okay, you have a containment mechanism where one containment mechanism is containing another containment mechanism. Okay, so it sounds like something that we don't encounter in real life, but we do. Okay, how many people have the experience of creating a folder inside a folder at some point in your life? Okay, so it is not uncommon that we do that, especially if you put all your homework assignments on the computer. So you might have one folder called Spring 2025, so that you put all the homework assignments related to this semester into that one folder, and then the previous semester would have a different folder called, guess what, Fall 2024, right? Okay, but within the folder Spring 2025, depending on how many classes you're taking, you might have one folder for CISP 300 for this class, another folder for Math 400 if you're taking Math 400, another folder for History 300 if you're taking History 300, and yet another folder called English Writing 300 if you're taking English Writing 300. So that's the concept of nesting. You have a folder inside a folder, and there's no limitation of how many levels of folder you can have. So within this class, you can have one folder for the first assignment, yet another folder for the assignment that is due next week. And then within that, you can have first attempt as a folder, second attempt as a different folder, and so on. So is that concept okay? The concept of just nesting. You can have something that is a container that by itself can be inside yet another container. Okay. So that's exactly the concept of else if. Okay. So when we look at else if here, line 4 to line 7 is a conditional statement. But that conditional statement is the else statement of the outermost conditional statement. Okay. Now it can be difficult to read, um, looking at this, but the picture that I have prepared here is me trying to make it easier for you guys to visualize the whole thing. And it's kind of hard to put the whole thing on the screen just because it is a little bit bigger. But you can see how the kind of yellowish, block here, that is a conditional statement. Does that look like a conditional statement to you? What should a conditional statement look like as a flowchart? Starting point, a diamond to deviate or to branch out into two different branches, something to do for each branch, and then they merge together. Do you see that construct in the yellow block? But a conditional statement itself is a statement. It is one of many types of statements, which means any place I expect a statement, it can be a conditional statement. So from the outer block perspective, what is after the false here? Well, we're expecting something to do, which is a statement. What statement are we expecting? Well, it can be an assignment statement, but it can also be a conditional statement itself. So this is where we contain an entire conditional statement as the else branch of yet a bigger conditional statement. So the entire picture, okay, let me zoom all the way out. Okay, that's a little bit too much. So this entire thing is one conditional statement. The else branch by itself, okay, let me zoom in a little bit here, is also a conditional statement itself. So I'll just kind of pause and see if that concept is understood. We're okay there. Okay. If you are to think of a form, okay, using the form analogy. So let me switch back to the form analogy. It is as if, okay, I'm gonna do this in a particular way if I can find my tablet because I'm using it and then I put it somewhere, which is here. Now I find it. So what that means is this block here, okay, this block here, if you expand it, it looks just like this because it is also a conditional statement. Are we doing okay so far? Are we doing okay with that concept? Okay. So nesting, which is what we're describing here, is how we can specify very complicated logic given a very small number of constructs. So how many constructs are we going to talk about? We are now talking about the conditional statement. We have a pre-checking loop, which is also called a while loop, and then we have a post-checking loop, which is what I call a do loop. Okay, now there are other constructs in C++, but I'm going to focus on these three. So in other words, there are only three control structures that we will talk about in this class. Control structure means the flow of the logic can go to different places. It's just not a sequence. There are only three. So you go like, how can we specify really complicated things only using three control structures? The answer to that question is they can nest. Okay? One thing can be inside another thing, that thing can be inside yet another thing, and so on. So that's how we will be able to specify complicated algorithms, given only like three control structures in this class. So nesting is not a concept that is commonly found in real life. Okay. In other words, I mean, you can kind of understand it a little bit here. Like a house has rooms, right? A room may have a file cabinet. The file cabinet may have different drawers. A drawer may have multiple folders, and within the folder, you might have pieces of paper that are stapled together. So that's kind of an example of real life, nesting. Okay, one thing containing yet another thing. But in programming, there's no limitation as to how many levels of containment you can specify when you're writing the code. Okay. Now, obviously, if you have like 6 levels of containment, that code is difficult to understand. Okay. And we have mechanisms to use so that we can, not make things really difficult to read. And we'll get to that when we get to that. It's called functions or subroutines. So those are the kind of like a preview of what we'll be talking about. All right. So we have about 5 more minutes. I want to have you guys to think about what questions that you might have at this point to ask me. Now, I do have office hours right after this class, and typically I have time in between this class and my next class, which is starting at noontime. So if you ever need any help with the class material, or you need some help, like I'm finding this stuff a little bit too abstract. What are some of the good strategies to understand something that's abstract, or how to approach something that's abstract? You're more than welcome to come to my office hour, and I will, kind of I will work with ChatGPT to try to find some answers and some solutions. Yes. Yep. Yes. That is correct. So the homework assignment is to ask you to make 3 trace tables. Yep. Because it says you make 3 sheets or 3 tabs for each of the following. Yep. Yeah. One. Right. Mm-hmm. And an example is already in the module itself. So if you go to this is a trace table for the case when all three variables have exactly the same value. But the important part here is, okay, let me go back to the default zoom. So the important part is you have to state the precondition. What are the values in variables w, x, and y? Now z is going to be unknown because we're going to use it to store the maximum. And then for line one, okay, you have to indicate the flow. So that means if line one, when line one executes, you have to tell me what is the result of executing line one. So in this case, when line one executes, it doesn't change anything because we're evaluating a condition. It doesn't change any variable. However, it has a conclusion. It says 2 is greater than or equal to 2 is true, so the condition is true. So if the condition of line 1 is true, then we proceed only to line 2. Line 2 is going to copy the variable w to the variable z, and therefore z gets a value here. And then after that, we exit the entire thing. So we go straight to post because there's nothing else that we need to do after line 2 in this particular case. So that's kind of the standard of how we trace a conditional statement. You have to indicate what condition we are evaluating on which line and whether the condition is true or false before you go to the next place to continue the execution of the code. Is that okay? Okay. Any other questions related to the content of today's lecture or the homework assignment? Yeah, sure. That is the precondition. Yes. Hmm. Yep. Hmm. It is what is basically is what is given to the algorithm. Yep, it's the starting. Right. So you always start with line one, okay, unless the program has a different numbering. So you always start with line one, but in this case, line one is okay. So the code that I'm tracing here is this code here. No. So if basically line one contains a condition that we have to evaluate. And it is basically a question of, is this true or false? So you have to tell me when we evaluate line one, the condition of line one, whether it is returning with a result of true or false, so that you can explain to me why we proceed to line two in the example that we were looking at. So in your homework assignment, you need to give me three different scenarios. In other words, each one starts with a different assumption of what values are in w, x, and y, but then each one will basically end up using one of the branches. So one trace or one tab is going to use w as the maximum. One trace is going to have x as the maximum, and then the last one is going to have y being the maximum of the three, and then you have to give me three different traces, one for each of these scenarios. Right. Okay. Any other questions? No other questions? All right. So try to read ahead of me, because I actually have another module ready already. And that's a really short one. It is about block statements. Okay, so let me go back to the top here. Um, So this is the block statement. The rest I'm not quite done yet. Okay. So block statement on the other hand is released. Okay. Once again, it has a little bit of BNF in it. Okay. What is the syntax of a block statement? And it has a little bit of explanation of why do we need a block statement. Okay. Because the oh the limitation right now is you can specify only one statement as the then statement and only one statement as the else statement. What if you have a few things to do for the then and you have a few things to do for the else? Right now, we don't have a way to do it. Okay. And that's why we need a block statement because a block statement combines multiple statements into a single block statement. Okay. It's kind of like you have a whole bunch of files. Okay, so think of this in Canvas. Okay, your professor says, okay, you have to turn in this file, and this file. But the professor accidentally make the upload interface and go like, you can only upload one single file. So what are you going to do? You zip it, right? You just zip multiple files into one single zip file and then upload that zip file. So the whole mechanism of a zip file is the block statement. It can combine multiple things into one thing. Is that okay? So think of it that way, because once again, I'm trying to relate what you already know and what you already do with the concept that we are talking about here. So try to read ahead, at least finish the block statement. Over the break or over the weekend, I should be able to finish the loops, and I'll make an announcement when that is available. Alrighty, I'll have a nice weekend. I'll see you all next Monday.